So what we're going to do is we're going to talk about this phrase. This phrase is very important, so write this phrase down. We're going to find the distance. We're going to do this kind of like three different ways. Okay, we're finding the distance from a point to a line. From a point to a line. So first of all, we have to define what that actually means. So let's draw a line. Let's draw a point. So here's a line, and here's a point out here like this. And let's make the next one different color. So if I asked you to find the distance from this point right here, okay, you see the point, to this line right here. If I asked you to draw that distance, or the word they're going to use in here, they're going to use the word construct. It just means draw it out, okay? That's all it means. So if you see the word construct, or if I say the word construct, it just means draw the thing. I say construct a line or line segment that's, or I'm sorry, construct a distance, all right, from a point to a line. So if here's the point right here. Now where would I draw this thing? Would I draw it to there? Would that, do you think that would be the distance from that point to that line? Do you think it would be from there to there? Okay, well this is straight, isn't it? Well, this is down, right? That would be up. That's down. Let's get a better word though. I know exactly what you're saying. I know what you're saying because every year in the class before you guys did this, thank you. Okay, it would be perpendicular. That's what I want to hear, okay? Because if you say straight, now listen, if you just said straight and down, that technically could be thought of as straight and down. Okay, I know what you're thinking. I know you're thinking right here, right? I know what you're thinking. But I want you to understand that it's not just straight down, because I'm going to show you an example here in a second after this one, that the distance isn't always just straight down. So what we're going to say, we're not going to say straight down, and I expected that. I mean, every year I ask that, and that's what I hear, and if I was a student, I'd probably say the same thing. Right? But when we're talking geometry, we're talking more than just saying straight down. That's not enough to tell how we're going to draw this thing. But we do say perpendicular, okay? That's the key. Now, is that perpendicular right there? Is that red one, that white one, are they perpendicular? Yeah. They are? How do you know? You don't know. Because it looks like it? You don't know. You don't know. How would you know? What thing? A little box, right? Okay, draw the little box. Now you can say that this is this red one is perpendicular to the white one. So this line right here is perpendicular to this white one, so we call this the distance. Okay, this would be the distance. Now notice, I didn't go all the way through, because if I went all the way through, that'd be a different length, wouldn't it? From this point to this point right here, where it hits, perpendicular, okay, that is the distance between a point and a line. Let's do this. Now, you guys said straight down. And again, I completely understand why you would say straight down, and it's not a bad... You know, it's not like bad that you said that, but it's not completely accurate, because what if I did this? What if I had a point out here like this, and I said, what is the distance from this point to this line right here? Now, would you also say straight down? Because that would be straight down according, right? So we don't say straight down. Do you understand why I was a little bit picky about not saying straight down? Because you don't always just say straight down, but you can say what? It's a line from this point, what to this line? Perpendicular to this line. Okay, now again, you can't say right now, let me get this right. You can't say that this is perpendicular yet, can you? Now, it may look like it, all right, but what if it's like 89.9 degrees? Is that 90 degrees? No, it's not. What if it was 90.1 degrees? Is that 90 degrees? No. All right, so it could be really, really close, but what ensures that it's 90 degrees? That little box right there. So that means it's perpendicular. So if I asked you to draw a line or construct a line or a line segment that is the distance from this point to this line, this is what you would draw. I would need to see the line, I would need to see the straight line, and I would need to see this being perpendicular. Okay, I need to see that little box right there. Does that make sense? Okay. Now, they're not going to ask you, they're not just going to give you a point and a line. What they're going to do is this. Let me show you. There's like 3 different types of problems they're going to ask you to do on this worksheet that I'm going to give you. This is the first type. Let's just draw it like this. Okay, they're going to give you a figure. One of the problems, they give you a triangle. They'll label the triangle. We'll call this ABC, and they're going to say, let me get a copy of the worksheet. I think they say construct. Yeah, they do. They use the word construct. Construct a segment that represents the distance indicated, and this is what they say. You want to go from point B to line segment AC. Okay, so you're going to construct a segment that is the distance. Let's write that in there. It's the distance from point B to line segment AC. All right? So what do? We come over here. I'm going to use a different color. You don't have to, but we come, here's point B, and we have to draw a line. That's what it means to construct. When it says construct, it says draw a line that goes from point B perpendicular to AC, right? They don't use the word perpendicular. They say find the distance. But you know now that the distance, we just define what it means to do the distance. Okay, it's perpendicular to here. So you make it look as perpendicular as you possibly can, all right, which is about right there. But is that enough? Can you just put that line and that's it? No, it's close, but you got to put that little box in there to indicate that it's 90 degrees. If you don't have that box in there, I'm marking it wrong. Everybody hear me on that? Because that, if I just put a line, how do I know, look, how do I know it's not that one right there? You follow me? Is that one perpendicular to this line? No, it's not. Okay, so would this be the distance from B to this? Would that be the distance? No, it wouldn't. You can only have one distance from this point to this line, and it's the one that's perpendicular. Okay? They could give you another problem. Let me show you another situation they could give you. All right? Now, you're going to see problems that are just like this. All right? So it's important that you pay attention. Write this down. I still see people, after I've asked you several occasions now, that are not writing stuff down. But again, I guess that's your problem if you don't do it. So let's label this ABCD. It's an ugly B. Let's try this again. All right, and they're going to say construct a segment that represents the distance, let's say from, I'll just make one up. Let's say from point A to line segment DC. All right? So if you have this thing drawn right there, what you're going to do is you're going to construct a segment from point A. So you're going to start right here. You have to start right here. And you're going to go to DC. Well, here's DC down here. Well, you got all kinds of places you could put it, don't you? But the distance, though, is always the perpendicular distance. So we can't go to here. We can't go to here. Where do we go? We go and make it look as perpendicular as possible. Okay? So this right there would be the perpendicular distance. And that's your answer. That's all you have to do. There's no math involved. There's really nothing. All you do is just draw a line, put a little box, and there you go. It's pretty easy, wasn't it? You can't get it wrong? Sure you can get it wrong. I just said there was no math involved. I said, but sure you could get this wrong. I mean, what if you didn't put the box there? If you didn't put the line there, it would be wrong, right? If you went from point D to somewhere else, or point B to somewhere else, it would be wrong. So yeah, you could absolutely get it wrong. If you go from point A to DC and you put a line in a box, then it's right. No, you can't put it anywhere. You can't put it anywhere. It can only go to one place. There's only one place where it's going to... All right, listen to me. Then it wouldn't be perpendicular. Listen to what you're saying. Look, if I went anywhere on the line, I can't just put a box there because that's not perpendicular. There's only one spot on line DC where this line is going to be perpendicular to it, and it's right there. There's only one place. You can't just take this and put it anywhere you want because then it's not perpendicular. Let's keep going. I didn't say that. You said you can't get it wrong. I never said you couldn't. Oh my goodness. Okay, let's keep going. Let me do another one. This one's a little trickier. Watch this. What if I said this? What if I said, let's erase this. Instead of that one, and let's erase the whole thing. Well, just that part of it. Let's go back to white. There we go. What if I asked you to do this? Go from point B to Let's go DC again. No, exactly right. Now watch this. Everybody watch. This is a little trickier, okay? If I start at B and I have to go to DC, now I can't just draw a line to here or here, here or here. Why not? Because none of these, nowhere on here is this line going to be perpendicular to DC. So what am I going to have to do? I'm going to have to extend the line, aren't I? I'm going to have to take line DC and extend it out. This is what they usually do in the books and stuff to extend the line. They usually show it as a dotted line. Okay, so if they take that line, they extend it out. All right, so I took DC and I extended it out. Now let's go back to red so we stay consistent with our colors. So now I'm going to start at B, and I have to go to line DC. But look, line DC ends right there, and it's not going to be a right angle, is it? It's obviously not a right angle. Okay, so where do we have to go? We have to go to about right there, don't we? And then we can go ahead and put the right angle. So this right there, even though it's not inside of the picture, that would be considered the height, or that would be considered the distance from point B to line segment DC. Actually, probably put line DC. They put line? Yeah, they put line. They don't put line segment. I'm sorry about that. They put line DC. All right, so we can extend it, can't we? And that's a line. So that is your answer. So this straight line in that little box, that's basically what the answer is to this, okay? But you should put the dotted line here to extend DC to show that it hits. So sometimes that distance is outside the picture, sometimes it's inside the picture.
So it's a line segment,
okay?
doesn't matter. Extend it.
Well, they do say line. I was mistaken to say line. Yeah, if they said line DC, there really would not be, or if they said line segment DC, there really would not be a distance from B to D to line segment DC because it starts here and it ends here, right? But they put line, and I mistakenly put line segment, but they do put line, so you can take this and extend it out because that is line DC. Does that make sense? Okay. All right, let me show you another type of problem they give you here. It's the same kind of deal. All right, here's another type. Now, it's going to look a little different because they don't draw the picture for you, but they give you some points, and you have to draw the picture, and then you have to draw the distance, okay? So they're going to give you something like this. They're going to say, find the distance. They're going to say, find the distance from point P. This is what the problem says, but I'm not actually asking you to find the distance. I'm just asking you to construct a line, okay, or a line segment that indicates the distance, okay? You don't have to actually find a number, but it says find the distance from point P to line L, all right? P is a point, L is the line. So here's what they give you. They tell you point P, and on this particular one, they say the point is 4, 3. All right? And where's line L? Here's line L. Line L is indicated by 2 points. Because if I have 2 points, I can connect the 2 points and I got a line. So here are the 2 points. 0, -3 is 1 point, and 7, 4 is the other point. And what do I have to do? Now, it says find the distance, doesn't it? But what are we doing? We're just drawing the line, right? Or what's the word that... Construct, right. Now, in the worksheet, it'll say find the distance, but I'm telling you to construct it, which means just draw the picture. That's all you got to do, is just draw the picture. You don't have to find a number answer. You don't have to do any math to find the answer there. All right, so let's do this. Where do you think we would start? Plotting the points. That's right, plotting the points. Exactly right. So you don't really need graph paper for this. You can just use regular graph paper. Just try to keep fairly accurate with your, with your 1, 2, 3, 4 and all that kind of stuff. So point P is at 4, 3. So we could plot that one first if we wanted. 1, 2, 3, 4, and then 1, 2, 3. All right, so let's plot that point. And we'll make this blue just to be different. 4, 3, it's about right there. And I'm going to label it. Call it point P. It's important that you label it. Hope you guys are watching. Now what we're going to do is plot the 2 points for line L. So let's plot those two. So 0, -3. So let's go back to white so I can put these little marks in here. 3, 1, 2, 3. 0, -3 is about right there. Actually, I should have done that in blue. Let's put it back in blue. And then what's our other point? 7, 4. So I got to count over 7, don't I? So So give me a second. So that's 4, 5, 6, 7. That's 3. That's 4. So that would be about right there. Okay. Let's make it blue again. There we go. So what are we going to do now? We're going to take these two, connect them. Actually, I'm going to extend it out just a little bit more. They don't have to start and stop at those points. They can keep on going because that is a line. So that's my line L. Everybody see that? See? That's line L right there. There's point P right there. What are we trying to do? Let's do this in a different color. We're trying to find the distance from P to L. So what do we draw? Perpendicular line. Okay. Now in the last class, I was a little bit more particular about, I think I'm going to change my mind a little bit, so I'll have to tell them tomorrow. But if you just draw it, I'm okay with that. So just draw it so it looks perpendicular, okay, and put the little box. If you don't put the box, it's going to be wrong. Make that look a little straighter. That's better, okay? No, you can put it here or here. It doesn't make any difference, all right? So that little distance right there, don't extend that yellow line because we're finding a distance. So this little yellow line and that little box right there is basically your answer. But what do I want, though? I want to see that line, right, plotted. You really should label these points as well. So let's do that. And let's label this point right here, 7, 4, all right? And let's label this point P as well, 4, 3. So I've labeled all these points right here. Let's label these 2 points, label this point, make sure you see the straight line. I want to see this little line right here that shows that they're perpendicular. Okay? Pretty simple, isn't it? All right, let's do another one. So again, you're going to have 3 types of problems on that. That's your second type of problem. The first type is like that triangle in that 4-sided figure where you had to draw it in there. That's the second type of problem. Here's the third type of problem that you're going to do. This time what they're going to do is they're going to give you 2 lines. So they're going to give you a line. They're going to actually give you the equation of the lines. All right, so here's 2 lines right here. What does it look like to you that's true about those 2 lines? They're parallel, okay? And if we put the little arrows there, that indicates that they are parallel. Now, right now we've talked about the distance from a point to a line, but what about the distance between 2 parallel lines? What do you think? Well, let's take somewhere on this line right here, this right here. If I wanted to find the distance from this point to this line right here, where would it be? Would it be to here? Would it be here? Where would it be? Would it be straight up and down like you guys said earlier? Like that? No, it would be what? It'd be perpendicular, exactly. So I'm trying to make it as clear as I can. So that would be the distance. That red line right there would be the distance between these 2 parallel lines. Look, was that a magical point right there that I started from? No, absolutely not. I could start from this point right here, okay, and then make that perpendicular. What do you think might be true about the lengths of both of those red lines? Yeah, they're equal to each other, exactly. So if I have 2 parallel lines, the distance is going to be the same. There's not going to be 2 different distances, are there? All right, they're going to be the same as long as the 2 lines are parallel. So it doesn't matter where I start. As long as I start at a point and I go perpendicular to the other one, then these 2 distances are going to be the same. I could sit here and do this all day, right? I could take another point, and as long as they're perpendicular, right, as long as they're perpendicular to each other, what's true about the lengths of all 3 of these red lines? They've got to be equal to each other, okay? What if the 2 lines were not parallel to each other? Watch this. What if I had a line like this, oops, and then a line like that? They're obviously not parallel to each other. But what if I did this? What if I started with a point right here, and let's go perpendicular to the other one, right? Because that's what we said, right? And does that look perpendicular? About like that? That looks pretty good. Okay, so that's perpendicular right there. Well, this one's not completely horizontal. This one's not horizontal, so that looks perpendicular to me. So look, what if I did another point on here and I still went perpendicular to this line? Now, if you look at it, Both of these red lines are parallel to each other, but look at the lengths of them. So if I start off with two non-parallel lines, are the distances going to be the same between this point and here and this point and here? No, obviously not. This one's way bigger than this, isn't it? Okay, so in order for these two distances to be the same, what must be true about the two lines that we're starting with? They got to be parallel to begin with. Okay, so they're not going to give you a situation like this. They're not going to give you a situation with two non-parallel lines and ask you to find the distance between them. Okay? So what we're going to do is this. They're going to give you two parallel lines, but they're going to give you the equations of the lines. I'm just going to make one up just to make it kind of easy. What if they said y equals 3x plus 2 and y equals 3x minus, I don't know, let's just say 5. Okay? And they ask you to find the distance. Now, they're not going to ask you to actually find the actual number that's the distance. Now, in our in the other class, in the not college prep, what do you call it? In the honors class, we actually did find the actual number distance. I'm not going to ask you to do that in here, okay? It gets pretty complicated. Even for them, it was really, really hard. They really struggled with it. But I'm going to ask you just to draw it out. So it's not that hard just to draw this thing out. So let's, but you got to know how to graph lines, though. And if I just give you a line like this in slope-intercept form, you should be able to graph the line. We went over that not too long ago. Let's do the first one. The y-intercept is 2, isn't it? So we put a little dot. I'll tell you what, let's do that in another color. Put a dot right at positive 2. All right, and then the slope is 3, isn't it? So we rise 3 and run 1. So rise 3, 1, 2, 3, run 1 right there. What do we do with both of those? Just connect them, right? And whoops, let's get right on the thing, about right there. And we'll extend this out a little bit like that. And there we go. We've got a line. So that's this line right there. Everybody should know how to graph a line given it in slope-intercept form, okay? Let's do this one right here then. This is, the only thing different is what? It's the y-intercept. So we go down to negative 5. 1, 2, 3, 4, 5. The slope is still the same. So if the slopes are the same, what must be true about the two lines then? They must be parallel to each other. So let's do this. The slope is negative 5. And I'm sorry, the y-intercept is negative 5. The slope is still 3 over 1. 1, 2, 3, 1 right there. There's the y-intercept. There's the slope. And hopefully these look parallel. I might have to adjust that just a little bit because now if you had graph paper, it would be perfect, but my lines might have been off a little bit. That's pretty close, okay? So look at those. Those are two parallel lines. But what am I trying to do, though? I am trying to find the distance between those two parallel lines. So I'm not finished yet. I want to find the distance between those two parallel lines. You have all kinds of choices. You could choose any point along here and make sure it's perpendicular to this. But what I would do is this. I would pick one of the intercepts, like this y-intercept right here. Take this and make it perpendicular right there. And that basically would be your answer. Okay? I'm not even asking you to find out what that point is right there. That's a little bit tricky. It's a little bit difficult. All I'm asking you to do is draw the two lines. All right? So here's the three things you need to do. You need to draw this line, and you need to draw the second line, and then the third thing you need to do is draw the perpendicular distance. Now you could have picked anywhere along this line. As long as it looks perpendicular to the other line and you put the little box there, that would have been fine too. Okay? It could have been anywhere along here. It didn't have to go from here to here. Okay? It could have gone from anywhere on this line as long as it's perpendicular to both of them, then that would be your answer. Okay? All right, so that's the kind of stuff they're going to ask you to do. All right, so this is a worksheet, and it's worksheet 3.6, and I think it's page 41. So if you lose it between now and tonight, or you leave it in your locker or whatever, you can always go to digital lockers, you can print it off, and then you've got it right for you. Okay, now look, you've got some time left here, and listen to me. You have some time left. This is not just going to be free time. This is time where you're going to actually work on this worksheet. Okay, so you're going to do three types of problems. Let's go up to the top again and just show you. You're going to have a problem that looks like this, and all you have to do is draw this distance, draw the perpendicular mark. Okay. There we go. You're going to have a problem that you're going to have a couple problems that look like this. You have a couple problems that look like this. All right, so you have three. One triangle and two of those four-sided figures. Let's listen, please. Then you're going to have one where they give you a point, okay, and they give you a line. They give you 2 points that make a line, and you got to find that distance right there. So you'll have several that do that. There's like 6 of them, I think. No, there's 4 of them. Okay, there's 4 of them that do that. And then, here's the bulk of it. They're going to give you 2 equations of a line. You need to graph them both and show the distance between those 2 lines. That's all you have to do. Okay, notice that the slopes are the same. If the slopes are the same, that means the lines are parallel to each other. All right. So that will be due tomorrow, but you're going to have a little bit of time in here to work on it in class.